Hi, everybody. Here's my first attempt at screencasting your note set for you. Sure, at some point along the lines of being out, I will stop forcing you to see my face. Bear with me. This is new tech to me, and, I'm not always great at things. So I wanted to start by refreshing your memory on the different types of observations or data that could be collected. So we're going to be talking about quantitative and qualitative observations today. And then I also wanted to refresh your memory on what accuracy and precision are, so that when we do get to looking at the lab that we stopped prior to seeing each other, you understand what I'm talking about. So here we go. To the best of my ability, you should be able to describe quantitative and qualitative data sets and understand how to record them. If we're just going straight up and talking about what qualitative and quantitative data are, quantitative are all of your numerical data, right? What you can count, what you can measure, you express using numbers, whereas qualitative describes the quality or physical properties of an object or substance, whatever you're looking at. It's descriptive, not numerical in its nature. Okay. In the last lab that we ran, you should be familiar with both the quantitative versus qualitative observations that you made about those 5 cylinders. So here's an example observation, right? Mr. Taylor was heating a test tube with 40 grams of baking soda over a Bunsen burner to see how much gas would be released. He collected 350 milliliters of carbon dioxide in an inverted collecting tube. The baking soda began as a fine-grained white powder and by the end had browned and become chunky. So those are the observations. And if you had to break those up between qualitative versus quantitative observations, you would make a chart and put the qualitative observations under one side. So the idea that it started as a white fine-grained powder is qualitative, and that it ended as a brown chunky substance is also qualitative, versus the quantitative information there is that you had 40 grams specifically of baking soda and that 350 milliliters of carbon dioxide were recorded or gathered, either way. Accuracy and precision. So this really does relate to the numerical data that we're going to be collecting and collected in the cylinders lab. And it's important that you understand the difference between them so that when I'm asking you to describe the data, you have different ways to do so. In terms of accuracy and precision, you should be able to explain the difference between the two and give examples of both. It's going to be a little harder than I thought. Here we go. So accuracy, you need to have a known value in order to determine how accurate your measurements are. If you don't know the known value, it's hard to determine your accuracy. So if a measurement happened to be 17.25 centimeters, which data set would you say is the most accurate? I'll give you a minute. Did you say the third set of data, the 17.8, 17.2, and 17.44 are all very close to, or at least closest of all the sets of data to the known value? How about between Susan and Amy? Again, if the length of a book happened to be 17 centimeters, who would you believe is more accurate? Did you say Susan? Well, you would be correct. Even though Susan did have measurements that were above and below, she's still more accurate, still closer to the 17 centimeters than Amy is. Precision, on the other hand, we talk about how often and how well you could repeat a set of data. So precision looks at the repeatability, if you will, of the data that is recorded. And this really will matter when we look at large sets of data if you ran multiple trials, or if we're looking at all of the class data, we would see how precise the class data is. How close are we in getting the same number over and over? So again, here's 3 sets of data. Which would you say is more precise? And again, you don't have to have a known value to look at precision. You look at the set of data itself. So did you say that first data set? Good job, because they are precise in nature. They are very close together, even though not identical. Okay. And again, we have Susan and Amy who measured a book. 17 centimeters is what the book should have been. Who's more precise in their data set? Did you say Amy? I would agree. Yes, Amy is off of the known value of the book of 17, but all of her measurements are similar, so her measurements are more precise. Perhaps she did not use her ruler properly, paying attention to where the 0 line fell, and therefore was slightly off, but all of her measurements are relatively the same, so she is precise, just not accurate. Another way of looking at accuracy and precision is to think of a dartboard, right? So if we're shooting for the bullseye and the arrows represent where your darts have hit, then this first dartboard represents having high accuracy. They're very close to that center, and high precision because all of the shots made were in the same general area. Whereas the other board here has low accuracy because they are far off of the intended mark, but still has high precision because they can group that set of throws. Hoping this is all making sense. Again, it's just meant to be a review of some of the things we talked about prior to leaving. All right, so here we have again just the idea of bullseyes, just to really drive home the idea of accuracy and precision. So you have 3 targets, each are going to be shot with 3 arrows. Oops, I did that a little too fast. How would you say they each compare? I'll give you a moment. Feel free to talk to yourself. I've been doing it quite often. If you said that that first set of arrows was both accurate, because we're assuming you're hitting the bullseye, right, and precise, you would be correct. How about the second set? It is precise, but it's off the mark, so not accurate. And how about that last one, which is really what my dart game actually looks like? You'd be neither accurate nor precise. I hope you enjoyed these note sets. Following this note set, you should be opening up the Google form and participating in the content quiz. Good luck. I hope you took notes. I'll see you soon. Bye-bye.